Thank you, everybody. Good afternoon, good morning, and good evening to you all. So in today's talk, I'm going to talk about the two popular programming models, MicroProfile and Spring. Actually, I focus more on the Spring Boot aspect. So I am Emily Jiang. I'm a Java champion. I'm a senior technical staff member in IBM. I'm the Liberty microservice architect. So I work mainly on open source projects like MicroProfile and Open Liberty. In today's talk, actually, I want to give you a kind of different perspective. So I'm not devalue any programming model. Basically, I want to put in a context for someone who knows Java EE. From this talk, you will know a little bit about Spring Boot. And for the people who knows Spring Boot already, hopefully in this talk, you will understand MicroProfile, which is directly built on top of Java EE. Next, please. Next, again, please. So MicroProfile has been around for a few years. It was established in 2016 by IBM, Red Hat, Payara, and Tommy EE and learned Java community. It's being hosted by Eclipse, so it's under Eclipse Foundation. So that's why it's called Eclipse MicroProfile. And then later on, Oracle and Microsoft and together Fujitsu and others all joined. MicroProfile is completely community driven. So it's there's no kind of major stakeholder and etc. It's a community decide what needed to be in the programming model. There's no reference implementation either. So there's like a dozen implementations. They are all equal because we don't want to differentiate which one is better, which one is not. So that's why we remove the concept or reference implementation. So the API and TCKs freely downloadable from Maven Central and Spec released in the individual MicroProfile specification release page. And we have very lightweight iterative processes to control the release. So basically every year we have 3 releases. Next, please. So in the MicroProfile community, as I mentioned earlier, there's a dozen vendors and Java user group. To date is about 169 individual contributors and is faster growing. About a dozen independent implementations as well. Next, please. So it's in the dozen implementations, there's Open Liberty, WebSphere Liberty from IBM, and Quarkus, Wildfly, and Songtail from Red Hat, Payara from Payara, and Apache Tommy from Tommy Tribe, and Helidon from Oracle, and Apache Launcher from Fujitsu, and Cumulus EE from Cumulus EE, and also Hammock is from community, and Prana is the new runtime being released last year. So it's the wiki page, wiki.eclipse.org/microprofile/implementations tell you everything about the implementation status and etc. Next, please. So in MicroProfile, as I mentioned earlier, every year we have 3 releases. So far, in February 2020, we have a MicroProfile 3.3 being released. So at the moment, the runtimes are trying to implement MicroProfile 3.3. So watch the space for the upcoming supporting runtime for this release. Next, please. So this is give you a quick summary about MicroProfile. As you can see, the green box is directly taken from Java EE, CDI, JSON, JSON-B, and JSON-P. All the blue ones being released is directly evolved in the MicroProfile community. Open tracing, health metrics, Open API, fault tolerance, JWT, config, and REST client. So they are on the left, they are all in the umbrella release. On the right-hand side, they are individual specifications because they are not in the umbrella spec, because we need to get more feedback before we merge into umbrella spec. So they are reactive messaging, reactive stream operators. If you are trying to do reactive, check these specifications out. And also the context propagation is for the concurrency programming model, basically which is context need to be available on the newly created the thread asynchronous. If you do a synchronized way, and for example, in fault tolerance, if you add asynchronously, it will spawn off a new thread. For this new thread is kind of auto control. You don't have any context associated to it. If you want to push CDI context, for example, you will need this context propagation to associate the particular context with the newly created thread. And then in the box in gray, this is upcoming specifications. So hopefully they will be released this year. So I would think in the 2Q, at the minimum, we should have this specification being released. Next, please. So this is give you a quick overview about Spring and MicroProfile. Basically, they are very comparable. And for example, get started, you have different starter. And also, when you create a microservice, the most popular technical knowledge will be REST. So it's in MicroProfile, we have JSON in Spring, you have a Spring MVC, and also dependency injection and API documentation, REST client, JSON-B and JSON-P, and also both programming model offer reactive support, and also for the operation team. And so for improve the quality service, we have configuration, also for tolerance, security, and from operation concern, you have health and metrics and distributed tracing. I will go through them one by one in the next 30 minutes or so. Go to next, please. So this is starter. If you have not looked at the MicroProfile starter, go to the start.microprofile.io, so you can fill in the artifact ID, and also you choose the MicroProfile version, and then is MicroProfile runtime, so you can choose your favorite runtime. And then some runtime also support Java 8 or Java 11. And then on the right bottom side, you have the example specifications. So to get started, I recommend you choose select all, so you can generate a demo app to demonstrate each video specification. On the right hand side, that's the start of Spring IO. When you create your first Spring app, you will use this one and directly create either Maven project or Gradle project. In MicroProfile starter, we have the Maven support. We haven't put a Gradle support as yet. Next, please. So in this talk, I'm going to focus on the cloud native point of view. So to get started, we'll say, how can you create your first microservice? As I mentioned earlier, microservice is kind of a small application. It will have exposed endpoint. How can you expose endpoint? Is a very good chance you will use RESTful API. So it's next, please. Next again. Thank you. So in MicroProfile, I'm sorry that the color is not very nicely viewable. So it's in the MicroProfile, you will use Jakarta. You will have two classes. One is application. So basically you have art application path. The other one, you will create RESTful resources. You will have art path as an annotation, and also you specify the format of this response. So you, in this example, on the left-hand side, you say, okay, this format on the wire will be application JSON. And then you can declare any get operation. And in this way, it will expose endpoint for each get operation or put operation, etc. In the Spring, again, it's very similar to MicroProfile. You have two classes. One is the Spring Boot application on the top. The other one is REST controller. So you have at REST controller, and also you also need to specify the URL. So here REST mapping value /atoms, and then it says is a get operation. So in Jakarta, you said @get, and in Spring you said request method .get. So this is very comparable. So basically this URL and very the way to do this URL very similar to MicroProfile Jakarta as well. Next, please. So in the with the RESTful API actually alone, you will be able to create a microservice. The next thing is also you can create a microservice, and you need to make sure internally, right? Internally, your microservice is very tidy. So how can I do the essential housekeeping? So you use dependency injection. Next, please. So in MicroProfile, we use CDI. So in CDI, the major thing is @inject. Basically, once you use the CDI, and you will not directly call into constructor anymore. You will need to use the CDI, this container, to manage all the instances for you. Basically, you say, hey, I need an instance for the inventory refresh task. And CDI container can directly create an instance, hand over to you. If this inventory refresh task is application scoped, is every time when you use @inject, you will get the same instance. It's no other instance, just one single instance. If it's a inventory refresh task, it said, hi, I am request scope. So each individual request, you will get a brand new instance. Similarly, in Spring, actually Spring support both JSR 330. So basically that's the injection, and also so which means Spring support @inject. Spring support @inject, also Spring support @autowired. So however, @autowired is used more than @inject. So most Spring developers are familiar with @autowired. Whenever you see @autowired, and if you want to think about in MicroProfile context, you will translate it to be @inject. Next, please. So next thing is how can we I create my microservice, and then is I upload, I deploy to the cloud. How can I document my API? How do I tell people what I'm capable of? So this is document API. Next, please. In MicroProfile, we use the MicroProfile Open API. So basically, this is a MicroProfile Open API actually is directly influenced by Swagger API. If you know Swagger API, you can see from this window here, from the right-hand side, the Open API response is very identical. It actually identical to Swagger API. So it's so in MicroProfile Open API, always did is publish a few annotations. Like on the top hand side is API response, basically give you some documentation. You can provide a response code and then provide a description and a content. And also in the also you can provide what this operation does. You can do the summary and also description. And in MicroProfile and with MicroProfile Open API, you automatically get endpoint, localhost, and then port and then / Open API. In Liberty, also we integrate with the Swagger UI as well. If you directly use the starter, MicroProfile starter, and you will get additional endpoint is / Open API / UI. So you will get Swagger UI so you can directly invoke the endpoint and see the see the documentation on the website. So it's quite neat. Next, please. Next. So document API in Spring. Basically, is Spring also have a kind of quite good integration with the Swagger. So you can directly include this snippet, the dependency in your Maven project is Spring Doc - Open API - core, and with this you will get an endpoint is version 3 / API docs, which is equivalent to MicroProfile's Open API. The other thing, the Spring also has the integration with the Swagger UI. If you put this dependency snippet in your Maven project, POM XML, you also can go to the URL swagger-ui.html. You can see the UI version. And in Spring, it has also has some annotations, controlled advice and response status. So you can add the response status like HP status not found, and etc. etc. So it's so basically the MicroProfile Open API is give you a little bit more annotations. And the Spring also give you some annotations as well for you to describe this each endpoint. Next, please. So up to now, you can create a standalone microservice. Remember to use JSON and to use CDI, and also to be able to document them. So next thing is microservice is not standalone. They will need to use invoke some other microservice. So we use which means microservice A might need to call into microservice B. So this is we call it a REST client. Next, please. So in MicroProfile REST client, this is not very visible. I apologize. This is the kind of the quality is quite bad. Let me just talk them through. So in REST client, in MicroProfile, basically you create on the top hand side, you create a interface. So public interface is gradually getting better now. It needs time to paint the frame. So this is you directly to a register REST client. Basically, in my example, A calling B. So in microservice A, you directly create the interface. Basically, the microservice B implement. So it is and then you do add register REST client, and then in your microservice A, in your JSON resource, you can directly inject this instance into your JSON resource. You can say add inject at the REST client, and also is the inventory service client. And with this, the MicroProfile REST client implementation will directly create an instance and inject into this info client, this variable. Similarly, in Spring, you use a thin client. So basically, is you can say you again is in microservice A, you create an interface like a microservice B implement. However, you annotate with a thin client, and then in your Spring controller, you say enable thin client. You can inject this thin client, like this inventory service client. Next, please. So this is a kind of you can with this REST client, you can connect multiple microservices, and when these microservices they communicate, they need to pass messages between each other. So in what kind of format this message need to convey? So it's I think it's now is a very popular format is JSON, so JSON format. So that's why we pull in the JSON-B and JSON-P in MicroProfile. Next, please. So in MicroProfile, we can directly use JSON-B and JSON-P from Java EE. You can use this API because it's automatically provided by MicroProfile. In Spring, actually, Spring also supports JSON-B. Also, I think Jackson was kind of more popular than JSON-B. However, Spring does support JSON-B. So it's on the bottom side, you can use Jackson or you can use JSON-B. Next, please. So the next page, in this page, I give you a kind of a bigger picture about how do you use JSON-B and JSON-P in MicroProfile. So basically, it's again, I mentioned earlier, in MicroProfile, you create a JSON resource, and then is either get or put operation, and then you can say add produces media type dot application JSON, and then you have a return type. In this return type on the right hand side is inventory list. This inventory list is just like a data model. So it's completely is frank module. So in this module, you don't need to put any special effort in this module, and you can directly create some variables and etc. It's no different from other module. And the beauty is the JSON-B, JSON-P, the implementation automatically serializes this object when it's put on the wire. And when the retrieve off the wire is automatically deserialized. So this is, you don't need to worry about anything else. Next, please. So that's the kind of up to now is imperative programming model. Basically, when I call imperative programming model is the kind of a point to point. You know which one you are calling into, and you know is the kind of service A call into service B. If service A is not broadcasting any messages, and the service A knows it's a consumer. However, is what will happen, like you want to stream messages, And also you want broadcasting messages. You don't even know where your consumers are, how many there are. So at the moment, a lot of people started using Kafka, which is a message broker. Basically, it's you can directly push a message to Kafka and then consume message from Kafka. So similarly, how can you use this one together with MicroProfile with Java EE? So in MicroProfile, we create the reactive programming model. And similarly, Spring has a Spring reactor and etc. is a Spring like a reactive programming. So it's in MicroProfile, we created at least two well-used annotations. One is at outgoing, the other one at incoming. So at outgoing is kind of publisher. So you publishing message to the message broker. At incoming is you create a consumer to directly consume from a channel. So in this example here, outgoing, I push message to a channel called channel, and then at incoming, I directly consume message from this channel. So, however, where this channel lives, that directly can configure in your microservice application. It could be you use Kafka, or could be you use active MQ or MQTT for etc. So this is MicroProfile reactive. Also, you can use some RX Java, this reactive programming APIs. In Spring, and also it has quite a good support with Kafka. So in Spring and on the top code snippet, you have a Kafka listener. Basically, this is a kind of Kafka consumer. So you can consume from which topic is users, and the consumer group is group ID. And the other thing is on the bottom hand side is Spring is a kind of a Spring publisher. Basically, it's a kind of sending more messages to Kafka. So you can directly inject a Kafka template, and then this is sending message can directly send a message to the Kafka template. Kafka template.send to which topic with which message. Next, please. So it's now is a kind of whole programming model has been done. So it's up to now you can do imperative or you can do reactive, and now it's that's a basic need that has been covered. So next thing is you want to improve your quality service. What if you have hundreds of microservices? How can you manage them? Next, please. So it's if you have hundreds of microservices, actually you want to also use the best practices as well, like a 12-factor app. And in 12-factor app, the third factor is configuration. So basically, it's kind of externalize your configuration. So if microservice A deployed to the cloud A, and then it can behave nicely, and then later on you deploy to the cloud B, and also is you want to control the behavior a little bit. You don't really need have to reopen microservice A and recode it and then change the configuration and upload it to cloud B. Obviously, if you externalize your configuration, you can directly control the config value in the cloud infrastructure. So that's the configuration. Next, please. In MicroProfile, we have a MicroProfile config. in MicroProfile config, it has a notion MicroProfile configure sources. So basically, you put all your configuration in the configure sources. So basically, on the left hand side in here, and you can create an Elasticsearch underscore URL, and then it's kind of indexed, and then doc type all in your configure source. This configure source could be in the environment variable, or in the system property, or inside your MicroProfile application. Or if you put it in the Kubernetes, you can put in the configure map. Or you could specify this in the in the Zookeeper or in database anywhere. And the beauty is with MicroProfile config, and no matter where your configuration is specified, you can use either the API like config provider.get config, and then config.get value and put in the property name and also the type, and you can retrieve the value. Alternatively, you can use the CDI. You can use the add inject, add configure property, and put in the property name. And MicroProfile config implementation automatically inject the URL and into this variable URL. Similarly, in Spring, again, it kind of, you can put the configure property in the configure source. In this way, you can specify in anywhere Spring kind of opening configure source. In this way, you can specify Elasticsearch, and then you can inject like a configuration properties with the prefix Elasticsearch, and then you can directly inject into all the variable there, and then you can do you can inject the whole class like Elasticsearch config into the config. So Spring actually is have the concept of this almost grouped configure properties. In MicroProfile is kind of flat. So we have the to-dos and trying to support similarly as this kind of structured configure sources as well. Next, please. So next one is how can you create like a resilient microservice? So how can you make sure your microservice behave all the time and under whatever the situation is? So in this case, you want to use a fault tolerance quality service to control microservices. Next, please. So in MicroProfile, we use MicroProfile fault tolerance. In MicroProfile fault tolerance, it has a few like annotations: retry, timeout, circuit breaker, fallback, asynchronize, and also has a bulkhead. So retry basically is if something doesn't work, you want to retry. That's pretty kind of normal. And timeout, if you have kind of time critical operation you want to control, under what time limit you must return a response to your customer. So this is timeout. If it's kind of, if you call into a downstream service and take longer to respond, and with this timeout plugin, and no matter what response you get back, but within this, for example, if you specify 2 seconds, if you don't get any backend response within this 2 seconds, you will return an error to your customer. So basically, with this with this error, actually you can trigger the fallback. So also with this operation, probably you need to think about what's the contingency plan. So you will use a fallback. So in this case, like if there's a problem and the fallback method, fallback inventory will be called instead. It will provide a kind of default response to you, to the customer. So in Spring, and also is it use historics, Spring historics, and also it has some annotations. In this one, it also Spring Historics has a fallback and has the circuit breaker, have a retry, and also has a bulkhead and etc. So pretty much similar to MicroProfile. So the only difference is the Spring is wrapped on the historics. In MicroProfile, different implementation has a different way to achieve this fault tolerance aspect. And some of them use, I think most of them do not use historics. Some of them, create their own implementation without using any third-party libraries. So in Spring, you can see in the historics command, you have a fallback method, and also you can have enable a circuit breaker. Next, please. So the next one is how to secure microservices. So it's security is very important in the microservice architecture. Let's go to the next slide to see what the difference between Spring and MicroProfile. Next, please. So in MicroProfile, is the security aspect is directly built on top of Java EE security. So it uses rows allowed. In this example here, this operation get JWT based value. It says actually only the access group protected allowed to use this operation. Others are not allowed to invoke this operation. So MicroProfile JWT directly built on top of JWT. However, it adds two claims. One is the UPN, the other one is the access group. The other one is the group. Basically, one is identify who the caller is. The other one is identify which access group this caller is from. So with that information, when the backend receives this JWT, it can open it up to find this claim to be able to tell whether, to determine whether the user is allowed to invoke this endpoint or not. In Spring, it has the annotation at enable web security, and then it directly inject the JWT config. So you can directly use any APIs in the JWT config to control your endpoint. Next, please. So the next one is hopefully I use the next few minutes to directly cover the ops aspect. Next, please. So the first one is your microservice need to communicate with the backend to see whether microservice is healthy or is ready to receive any request. So the first one is MicroProfile provided the readiness check. Basically, this is determining whether this microservice is ready to receive any request. The next one, the second one is the liveness check. So basically, with at liveness, so that means you can directly put any logic in there. See, with at liveness, you can say, okay, maybe you run out of memory and etc. This microservice is going to die, and this payload will directly exposed under the endpoint /health/live. Similarly, the previous readiness check will be directly exposed to /health/ready. So in Spring, it has one endpoint exposed is /health. So you can directly implement health indicator and again put in your business put your algorithm there to determine when to make the /health respond the error code and etc. And if you want to use the Spring with Kubernetes properly, you have to create another endpoint one is the kind of /health, the other maybe you want to /health, /live, or /ready to be able to plug into the Kubernetes liveness and readiness check. Next, please. So the next one is how well can you know whether the kind of your microservice is behaving? Obviously, you will need metrics data. So in MicroProfile, we have a MicroProfile metrics. So it's these MicroProfile metrics you can directly plug in with Prometheus or Grafana. Is kind of directly, and then it has a few annotations at times to calculate how much time is used for invoke each the corresponding operation, or count it how many times it been invoked, and metered all the kind of calling frequency and etc. In Spring, it has kind of equivalent. You have a counter service. Again, is the Spring actuator can plug in. It has a counter service. You can figure out how many times this endpoint has been called. Please, next, please. So the next one is tracing aspect. Again, is previously I hinted your microservice is not standalone. It may call into, quite a lot other microservices to fulfill operation. So it's however, if you do not know how many microservices involved in a particular operation, if that operation is not going well, you need to figure out which microservice is having a problem. So with this, you need tracing this invocation. In MicroProfile, we have a MicroProfile open tracing. So with this, it can correlate all the trace ID. So basically, it's for each operation, you can go to the tracer, like the tracer, like Yago or Zipkin, and to be able to see the whole tracer. So basically, you can see all the trace span to associate with one operation. If something is not working, and you can see straight away. In Spring, it has a Spring Cloud sleuth, and all the kind of the invocation chain will automatically trace. In MicroProfile, is all the Jakarta invocation automatically traced, and also you can add some additional trace, like you use add traced to any other particularly non-Jakarta method, and etc. Next, please. So this is the final minutes, the takeaway. So basically, is what I want to say is both MicroProfile and Spring and provide developers the good programming model for doing microservices. So developer can choose whatever they want. So if they have a Java EE background, maybe they will find MicroProfile is easier. If they are comfortable with Spring, yeah, they can continue with Spring, because both of them are pretty good technology with cloud native application development. And also is a lot runtime application servers support both, like OpenLiberty, we support both Spring and MicroProfile. And you are free to choose whatever the programming model you want. Spring has been around for probably more than 10 years and quite popular. And MicroProfile and Jakarta are evolving rapidly, and it's gaining momentum since last year. And both Spring and MicroProfile and provide next generation cloud native application development for the cloud. So they are quite similar from what I have demonstrated in the previous slide. However, there's some differences as well. Next, please. So this is slightly kind of very like a manner, a very simple way to list all the differences. So MicroProfile is open source, so driven by the community. It has a dozen implementations. Spring is provided by Pivotal, so convention over configuration. And MicroProfile is open standard, is behaving in like accordance with the specifications, so that different vendors come together and also community come together to agree on the specifications and etc. And also in MicroProfile, if you use a different runtime there's a kind of server configuration, but it's very minimal. Your application APIs will continue run without any problem. You don't need to change your code whatsoever, and you can get it running on the different runtime. And in Spring there's a lot of APIs for you to choose from. You can do whatever you want. And the other thing is the MicroProfile implementation provide all the kind of APIs for you. The implementation for you, you don't need to package them. The libraries with your microservice. So in your POM, all you need to say is you depend on the MicroProfile APIs. In Spring, in Spring, you will need to bring your dependencies. You can say, okay, which dependencies you want, and etc. Put in your POM XML. And in MicroProfile, we promote theme walls, basically because all the implementation is in the MicroProfile runtime implementation. Your application is pretty much small. You only contain your business logic. In Spring, you can either do fat jazz, basically you package all the libraries with you, or you use Zip for containers to come up with a small jazz. With that, that's all for the comparison. Can you go to next, please? So the final page is the references. Basically, is all this talk is directly taken from the IBM Blue Computing exercise, migrate Java microservice from Spring to MicroProfile, the series blogs, so you can check it out. Also, I wrote blog under Eclipse newsletter. And then check out microprofile.io and also spring.io. And if you want to try some lightweight runtime, you can go to openliberty.io, or you go to others, Piara or Tommy or Quarkus to check it out. If you want to get in touch with me, follow me on Twitter, Emily FH Jiang, or ask me any questions. That's all for this talk. I apologize for a few minutes over. Are there any questions?
So let me see if we have any questions. I was not looking at the chat at all. Well, of course, everyone is saying thank you. Well, not everyone, but a lot of people are thank you, and they're happy with the good comparison between the two frameworks. The stream is available right away at the same link as sorry, the recording is available at the same link as soon as the session is over. So you can definitely view the recording. It will be also available off of the Meetup and the YouTube channel as well. So it will be available for reviewing. What else? More thank you. Any questions for Emily? It seems no questions, Emily. Again, thank you from my side. As always, it's a pleasure to talk to you and listen all the things that you can share with us with regards to MicroProfile, and not only MicroProfile, but in this case, MicroProfile.
Yeah.
So we will be in touch, and please stay tuned for the next Tech Talk, as well as I think tomorrow we have a Jakarta update call. So please tune in for more news on MicroProfile and Jakarta E. Stay in touch, and thank you so much once again.
Thank you.
Okay, bye for now.
Bye.